Lesson 1D, modeling with linear functions. Okay, graph. We're going to graph y equal to x. What does y equal to x look like on a graph? X is the input, y is the output. The way we did figure out what does the absolute value function look like, we did a table of values. We will do the same thing here. So for the inputs, we're trying to figure out what is happening here at the origin. So we use which numbers? -3, -2, -1, 0, 1, 2, 3 as a rule of thumb. So we're going to input x is -3 and see what the output is. So when x is -3, what would be the output? Well, for this to make sense that it is true, -3 has to equal to -3. -3 has to equal to -3. So the input is the same as the output. So then we can just go ahead and do -2, -1, 0, 1, 2, 3. So now we have the graph 0, 0, 1, 1, 2, 2, 3, 3. On and on and on. All right. So let's talk about domain real quick here. So the domain, and I talked about it last time, is that in the table, I didn't have to just use -3, -2, -1, 1, 2, 3, 4, and that's it. I could have used -4. I could have used -5. I could have used an input of -1,000,000 if I wanted to. And for an input of -1,000,000, I'll get an output of -1,000,000 as an example. So it's going to go forever down. That's why we put arrow heads on it, is that will go forever down this way, and it will go also positive forever that way. So inputs is that it has all possible numbers on the number line. So when we talk about domain, which is all possible inputs, the domain will be all reals. And we have this weird looking little R for all reals, meaning that all possible inputs is all the real number line points, inputs. Range, what's the range? What's the range? The range deals with all the possible outputs. So the outputs, it will go forever up as well, forever up. You can never crop it, because even if you try to crop it, it will always be sticking out like this. If you try to crop it, it's sticking out. So it will always be going up as well. So that one's also all reals. Okay, so that's something we're going to talk about even a lot more in the chapter 2 and on beyond. Okay, so we got our line. So now, in chapter, in lesson with absolute value, we did transformations, and we can also apply transformations to other functions, including linear functions. So let's go ahead and do work on this with transformations. So if I told you that, okay, this is x and this is y, and we remember that putting a negative in front of x, absolute value of x, what did it do to the graph? You remember that the v is the absolute value of x, and if you put a negative in front of it, it flips it, or it's called reflected about the x-axis. So when we do have this line going like this, and we put a negative in front of it, if I do the first transformation, I say, what does y equals -x look like? It will reflect it about the x-axis. So then instead of going up right here, it will instead of flip down to this part like this. So then this is going to go like this, and then this bottom part is going to flip to the top going like this. So there's that. We got that so far. So now we're going to do the next transformation, which is this. Y equals -x plus 3. Means that we're going to shift it up 3. 1, 2, 3. And now we got the graph going like this. And we are done. There's the graph. Let me remind you on what you should have done a lot in Algebra 1. There's another way of doing this, because it's very special in its way. It's called y equals mx plus b. You guys remember y equals mx plus b, where b is the y-intercept. This is another way of looking at it. The y-intercept, where it crosses the y-axis. This is the slope. And so the y-intercept is where it crosses the y-axis. So you notice that it crosses it at +3 on the y. And then this is slope. It's going down 1, make it a fraction. There's an invisible number 1 there, 1 over 1, because it's rise over run. We're going down 1 over 1. We're going down 1 over 1, down 1 over 1, and we get the line as well. So that's how we're going to do it. The next problem, doing it with y equals mx plus b. Let's go to number 3. It's telling us to change it to slope-intercept form and then graph the equation. Y equals mx plus b. It is not in y equals mx plus b form, so we need to put it in y equals mx plus b form. So to get the y by itself, we're going to add 2x to the other side. Move this over to the other side. Cancel. Negative 2x and positive 2x cancel out. So we get y equals. Now here's another thing you guys make a mistake on. The 3 does not have an x. They are not like terms. You don't combine them. You put them next to each other. So put the 2x, then put the +3. Now we got this y equals mx plus b, where b is 3, m is 2, and we graph it. So here's the parent function, y equal to x. This is y equal to x. We're going to do the transformations. In this one, I like doing this first, then this. So it's going to be rise up, it's going to be moved, this line is going to move up 1, 2, 3, and we have it like this so far. But it's telling us to change the slope of it. It's going to be up 2 over 1. So instead of having to go like this, you're going to move it instead. The next point is going to go up 2 over 1. So now the line should be like this instead, because we're doing we're stretching it up. So this should be the new equation, the new graph right here. Not this one, but this one right here. All right, next. Let's get the y by itself, put in y equals mx plus b form. Add 3x, cancel. Y is going to equal to 3x minus 4. And we're going to go ahead and graph this. This line is going to move down 4. We're going to move it down 1, 2, 3, 4. It's right here. And let's already do a rise over run, 3 over 1. From this point to get another point, rise up 3 over 1. And there it is, rise up 3 over 1, go on to another point. And there it is. Next, let's get the y by itself. Step 1, add 6x. Cancel out. 8y is going to equal 2. Again, put them next to each other. 6x plus 24. Divided by 8 on both sides. To get the y by itself. You're going to divide 8 into 6, and then you're going to divide 8 into 24. This one, you can get a whole number. 24 divided by 8 is 3. 6 divided by 8, that's going to be a decimal. If you put in a calculator, we want to keep it as a fraction, but reduce it some more. So what's the biggest number goes into the 6 and 8? 2. So that's going to give you 6 divided by 2 is 3, 8 divided by 2 is 4, 3/4 is reduced, 3/4. Don't forget this x, bring it down. And there it is, y equals mx plus b. Now we can graph. Move down 3. Rise up 3 over 4. 3 over 1, 2, 3, 4. There it is. Did I say? So we all make mistakes. It went up 3. Up 3. I don't know what I was looking at. And then 3 over 4. Up 1, 2, 3 over 4. There it is. All right, let's try not make a mistake on the second one. All right, or number 6. trying to get the y by itself. Add 4x. Cancel this. 12y equals 4x minus 36. Divide by 12. Divided by 12. Y equals negative 36 divided by 12 is negative 3. 4 divided by 12, one more time. That's it, 4 divided by 12, yep. So 4 divided by 12, we got to reduce this. It's going to be divided by 4 top and bottom. The biggest number divides into top and bottom. 1/3. So you're going to get 1/3 x. All right. So that's the equation we're going to graph. This time it is going to go shift it down 3. The y-intercept is down 3. And then rise up 1/3. 1/3. There it is. Something like that. Moving on, next. So use the graph to write an equation of the line and interpret the slope. So we got this where the title is important to pay attention to. This is a child's weight, and I hope it makes sense that a child's weight, hopefully he's well fed, and his weight is growing at a constant rate of change. That's why it's a line. So it's not really very real, but somewhat could describe the child's weight as he grows older. So the child's weight when he's born is about right here, which looks about 15 pounds, because this is weight in pounds, and this age in years. So at year 0, he's about, let's go with 17. That's just you could go 16, maybe 15, I don't know. And then he's growing. So they give you these 2 points. They're giving you this point, and they're giving you also this point. So it's saying that from year, this is 0, this might be 1, this is 2, this is 3, this is 4, this is 5. So between 3 to 5, from 3 to 5 years old, he increased his weight 10 pounds. That's slope. So how many pounds did he go up from t equals 3 years old? He weighed maybe what? What does it say? Maybe 15, you could say 15 pounds. Then by the time he was 5 years old, he weighed not 15, it's 25, man. 25. Ooh, take a look at this. Well, 20, this is not 25. This is 30, come on. This is 30. This is 10. 10, 20, 30, 40. That makes sense. So at 3 years old, he weighed about 30 pounds. At 5 years old, he weighed 40. So he increased by 5. You see that? So it'd be 10 in 2 years. So in 1 year, he increased his weight in 5 pounds. All right. That's how you interpret this kind of thing. So let's go ahead and do it. So then y equals, he was born weighing 17 pounds. That was one big baby. At time equals 0, he weighed 17 pounds. Then he increased his weight every year. It's linear, 5 pounds per year. So 5 pounds per year. X is years. Flowers remaining. Pay attention to this again. Flower remaining. So flower cups. So when there's flower remaining, see the input is time. Is no longer time. Here, this is time. So the weight of the child depends on time. In this one, the amount of loaves of bread depends on not time but on cups. So it's depending. The independent and dependent are different. So let's go with once there were no cups left of flour, we had made 20 loaves of bread. You see that? So 0 cups left of flour, we had made 20 loaves of bread. So let's go with the y equals mx plus b to describe this line here. So at time equal, so the y-intercept is 20 right here. This is 20 for sure. Now m is the slope. Slope is that, so this is kind of weird to interpret in real life. So what it says is that for, let's see. 11, see, this is weird because it's pointing down right here, and then it's pointing to the right here. So for 11 loaves of bread that were made, we used up 4 cups. So look, the line is negative. So this is a negative slope. So this is a positive slope. So when it's positive, this m better be positive, the m. And when it's negative slope, this better be negative. So let's see here, how can we make sense out of this? So we subtracted, the 4 went down in reality. Let's see here. It should be negative, okay? So how can we interpret this? It takes 4 cups. It takes 4 cups to make 11 loaves of bread. And the slope is negative. Just understand this, pay attention to the negative slope. And so that's it. We're done with this one. It takes 4 cups of flour to make 11 loaves of bread. And we're done.